So this is the lesson for 10-2. What we're dealing with today are rational and irrational numbers. You have to tell the difference between a rational number and an irrational number. A rational number is a number that is a terminating or repeating decimal. The word terminating means that the decimal stops. And then we talked about repeating decimals yesterday where they go on and on and on and on. It includes all fractions and all percents. So let's take a look at some examples of rational numbers, all right? Some examples of some rational numbers. Every single fraction that you can think of is rational. So if you had the fraction 1/2 is a rational number. If you had the fraction -1/3, fractions can be negative, that's fine. You can have an improper fraction where the number on top is bigger than the number on the bottom, so like 12/10, right? So you can have a improper fraction. You can also have a mixed number. If we had like 2 3/4, that's a type of fraction. It is rational. All terminating decimals. Terminating decimals are decimals that stop. So a number like 0.5. 0.5 terminates or stops after the 5. 1.73. It stops after the 3. You could even have a little bit longer one, maybe 7.5649. It stops after the 9, therefore it's rational. All repeating decimals. So anytime that you see that repeating sign, so like 4.3 repeating, you might have 2.61 with the bar over the 6 and the 1. Remember that you might see these numbers written a little bit differently. 4.33333333333 with a ... at the end. That is a repeating decimal. Or here with 2.61, you would see it as 2.61616161 ... at the end. They could be negative as well. All right, all of these decimals, you could have a -1.73, you could have a -2.61, positive and negative, it doesn't matter. Any number that you write in front of a percent sign, so like 75%. You can have decimals with the percents as well. If something went up by 3.6%, any number in front of percent sign is rational. Now, here's where you have to be careful. Some square roots and some cube roots, all right? Notice the word some. Not every single square root, not every single cube root is rational. We'll see some of them that are not rational in a second. If you go and type in the cube root of 512 in your calculator, all right, this cube root of 512, when you type it into the calculator, you get an answer of 8. 8 is a rational number. Any whole number or any integer, automatically rational. The square root of 0.25, all right, when you type that into the calculator, you get an answer of 0.5. 0.5 is rational. The square root of 25, when you type that into the calculator, you get an integer or a whole number of 5. 5 is a rational number. So we could actually add to this list of rational numbers any integers, right? Any integers, so any non-decimal numbers. So for example, 1 or 5 or 13 or -14, they could be positive or negative. Be very, very careful with numbers like 22/39. 22/39 is a fraction, so it is rational. But when you type it into the calculator, you get 0.564102,564. You have to be careful on the calculator. You have to be able to recognize that this is a repeating decimal. Notice how it goes 0.564102, but then it starts going 564 again. you have to, on these calculators, make some assumptions, right? The calculators are limited to only putting 9 numbers after the decimal point. You have to sort of look and see, hey, it's going 5, 6, 4 at the beginning, and then all of a sudden it starts going 5, 6, 4 again. You can just make an assumption that after the 5, 6, 4, it keeps on going 102, then it goes 5, 6, 4 again, then it goes 102 again. That makes it a repeating decimal. You have to really look and see your decimals and see if there's going to be a pattern there that is repeating. So the opposite of rational numbers is an irrational number. An irrational number is a non-terminating. Non-terminating means that it doesn't end, all right? Non-terminating goes on forever and ever and ever. Non-repeating, so that means you can't use a repeating sign, but it ends in ... It fills up the whole screen on the calculator. The way that I like to think about these irrational numbers are the big, long, ugly decimals. All right, they're the big, long, ugly decimals that fill up the whole entire screen. You can't use a repeating sign. They don't stop. They're the big, long, ugly decimals. Those are the ones that are irrational. The most famous irrational number, and this is very, very important for next year when you're in 9th grade in algebra, pi. Pi is the most famous irrational number. There is a pi button on your calculator. When you hit that pi button on the calculator, it says that it is 3.141592654 ... Pi keeps on going on forever and ever and ever. It's been calculated to trillions of places. It never stops. It never ends. All right, it doesn't repeat. It keeps on going on and on and on forever. Notice that I can't use a repeating sign anywhere here. There is no repeating pattern in this number. Therefore, it is irrational. All right, it's that big, long, ugly decimal. If you type in the cube root of 66, notice that this says some square roots and some cube roots. Anytime that you have a square root or a cube root, you have to type it into the calculator to be able to tell. So the cube root of 66, when you type that in, you get 4.0412400021. None of those numbers are repeating. There's not a pattern there. It goes on and on and on forever. Therefore, it is irrational. The square root of 2, 1.414. It looks like maybe it's going to start repeating, but then they get a 2 and a 1 and a 3 and a 5 and a 6 and a 2. It's not repeating. It's a big, long, ugly decimal, fills up the whole entire screen. Therefore, it is irrational. Sometimes they will try and trick you with some of these, all right? Now, this first one is not a trick question. It's just a big, long, ugly decimal. Fills up the whole entire screen on the calculator, and it's not repeating. But take a look at this middle one. Negative 20.1, what do you think that next number is? 8. So there is a pattern there, but the pattern is not a repeating pattern, all right? It's not a repeating. I can't use the little bar over it, and it's not repeating the same number or numbers over and over and over. There is a pattern there, but it's not the same pattern over and over. So don't get tricked by one like this, where you can guess what the next number is going to be, but you can't use the repeating sign. All right, so this is still irrational. Same thing on this one, 0.122333444 55555 666 You could probably guess the next number in the pattern, 777777. There's 7 sevens. All right, but I can't use the repeating sign to get those next sevens. So I can't use the repeating sign, so therefore it is irrational. So big, long, ugly decimals that you can't use a repeating sign are irrational, all right? They will fill up the whole entire screen on the calculator. unless they are repeating. Go ahead and try these 8 questions, please. What you're going to have to do on your homework today is you are either going to have to write in a R for rational or I for irrational. So remember, all rational numbers include all integers, all fractions, all terminating decimals, repeating decimals. Anytime you see a percent sign, automatically rational. The only ones that you need to type into the calculator are square roots and cube roots. Irrational numbers are your big, long, ugly decimals. Go ahead and try 1 through 8, please. All that you need to do is write in I or R. I or R. I or R.
Hey, Michael White, could you call 3102 Michael White 3102?
Trying these 8 questions right now. Questions right now. Trying these 8 questions right now. This requires writing. This requires writing. Stack the paper to pen.
This calculator is wrong.
Answer. First. So again, the only ones that you need to type into the calculator are your square roots, like number 1, your cube roots, like number 6 and number 7. The other ones you can just tell from looking at them, all right? So when you type in the square root of 400, the square root of 400 is 20. 20 is an integer, so 20 is a rational number. Pi is the most famous irrational number that there is. In question number 3, 73.454545 ... This is a repeating decimal. Every repeating decimal is rational. Number 4, 9.10102030508013. There's nothing there. You can't use a repeating sign. Therefore, this is irrational. In question number 5, any percent is automatically rational. As soon as you see that percent sign, automatically rational. The cube root of 0.027. When you go to type that into the calculator, 3, second button, caret button, 0.027, hit equals, you get an answer of 0.3. 0.3 is a terminating decimal. It stops. Therefore, it is rational. The cube root of 6, 3, second button, caret button, 6, hit equals. You get a big, long, ugly decimal. 1.817120593, blah, blah, blah at the end. Keeps on going, fills up the whole screen on the calculator. I can't use a repeating sign anywhere here, so this is irrational. Any fraction, any mixed number, automatically rational. Questions on those? Go ahead and try 9 through 17, please. Go ahead and try 9 through 17, please. Again, the only ones that you'll need to type into the calculator are 9, 14, and 15. There are only 3 of them that you have to type into the calculator. The square root of 4, all right? Second button, x squared button, 4, hit equals, you get an answer of 2. 2 is an integer, so 2 is rational. In question number 10, 15.1111 ... at the end, it is a repeating decimal. I could really write this as 15.1 with a little bar over the 1. Therefore, this is rational. 173.4, it is a terminating decimal. It stops, so it is rational. Number 12 is 9. 9 is an integer. It is rational. Any type of number that stops like that, automatically rational. In question number 13, any type of percent is automatically rational. As soon as you see that percent sign, automatically rational. The cube root of 64, 3, second button, caret button, 64, hit equals, you get an answer of 4. 4 is a whole number, it's an integer, so that is rational. The cube root of 18, 3, second button, caret button, 18, you get a big, long, ugly decimal, 2.62. 0741394, blah, 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 fills up the whole entire screen. I can't use a repeating sign anywhere there, so this is irrational. 4 2/3, any type of fraction, automatically rational. And number 17, a big, long, ugly decimal. I can't use a repeating sign anywhere, therefore this is irrational. So again, the only type of numbers that are irrational are your big, long, ugly decimals that you can't use a repeating sign.